like the grade of like people at a bar. I don't know how to say that. Like, um,
So, so it's like the like you said the word they're looking for something a local bar survey. I mean, is
uh-huh.
really what I guess you could call it.
Okay.
That would be fine. And it's class, it's frequency or count on the other axis. So then you grab the data one more time and you go to insert recommended charts. There's your pie chart. And we can use the same title for this. Making use of copy and paste. All right. You can resize these things, I guess. I mean, you want to make sure your teacher can find it. It doesn't look very good. I don't know. You can also make these in their into a new tab if
Okay.
you really want. But that looks pretty good to me.
Yeah.
You can make these pie chart pop out. So if you're doing a presentation in real life, like these look awful, like don't put these up in front of people. They'll think you can do better. Like, and it's all built in. Like you don't have to, you just have to click on these things for it to
Yeah.
look pretty. It's
Okay.
like a filter on social apps.
Got it.
All right. Next question here says the function normal distribution. Okay. Uh, Part A, compute the probability that an observation from a normal distribution is less than 7. Okay. So this is just, the teacher just wants you to, that's just calculation. So going, click the plus here, we'll call it exercise 2, 2. I'll zoom in here. I don't even know what I was at in the previous one, 150. Okay. So it's always good to kind of label like the part for the person grading it. That way they
Yeah.
don't have to search for it. Um, I don't know how they're going to grade this, but maybe you do. Compute the probability that an observation from a normal 3, 5 population is less than 7. So in Excel is the normal distribution function, and X is the 7 in your problem. The mean is 3. Now, normally that second number, that 5 on the, if you're looking at that, is
Hmm.
usually the variance. I recall there being like a discrepancy. You know if that was standard deviation or variance?
We use standard deviation.
Yeah, but that second number sometimes is
Wait a second. Oh, like the mu?
no. It's in if you look at if you read under A, just compute the probability that an observation from a n 3 comma 5. The Let me see here. Oh, your teacher using standard deviation. Okay, I answered
Yeah.
my question. 5 comma true. There's your answer for part A.
Okay.
So nothing really interesting there. Um, Now the next one is more difficult. You're going backwards. So this time use what's called inverse norm. Actually, it's norm dot inverse. And the probability this time is 0.75. That's what's given. The mean is 4. The standard deviation is 4. That's all it needs. So there's your answer. Does it say anything about rounding in there?
Let me see.
I'm not seeing it, but it doesn't
I
mean it's
don't
not in
think
there.
so.
It looks bad when it's not rounded, but hey, they didn't specify.
Yeah, we haven't really been rounding, especially with these ones.
All right, so part C, it says Taylor wants to be the last part there. Set taller than 73% of the other girls her age. So that's it. That calculation is like the previous one. Uh,
Hmm.
but this time it's not 0.73, it's 1 minus 0.73 because that's you want the area to the right of that
Oh
if she's
yeah.
taller than them. And so the mean here is 64. deviation of 3, and there's your answer.
Okay.
All right, I'm going to do the smart thing here and save this file before we get too much further into it. Right back with you. I don't know what kind of stuff it shows you when I save files, so let me get that
Okay.
in in there. Notes. All right. There it is. Hopefully we're back sharing now. All right.
Yeah.
Have you seen any questions on exercise 1, exercise 2 here? Proceed to exercise 3.
No, I
I was
don't.
thinking that we were going to talk more about rocks. I remember that being a common thing that
Oh
your
my gosh. They're
instructor.
all of our quizzes in class are about bears. And
That's right,
then
bears.
bears, rocks was like the midterm review theme. I think the midterm I took the other day was about like wizards and goats or something. Like this is awesome. I
Yeah.
just learned to just ignore the first 8 sentences.
Yeah, exactly. Exactly. All right. So to create 2 sets of 15 random numbers uniformly picked between 0 and 10. Label one column of numbers the X coordinate, the other columns of Y. So here we go. So here's X. Let me increase the zoom. X, and this is Y. Okay, so if you do this rand between, which is 0 to 10, you will see that it picks a number from 0 to 10. Now,
Mhm.
one of the problems with using this is that it continually updates itself,
Oh,
which is bad for like what you're doing. So what you can do here is you can actually paste just the numbers. Like let's say I like that data set, remove the old ones and put that in here. And now you've
okay.
got your data.
Yeah.
I always
That's
like to center my data. That's just kind of a thing I always did. Uh, it just makes it look a little bit prettier than just all over the place. So it says create 2 sets of 15 random numbers uniformly picked between 0 and 1, 0 and 10, label one column X, the other column Y. Give a brief explanation about what you expect the correlation coefficient to be and why you observe any deviation from what you expect. Okay, so this is where you will insert a text box
hmm.
and you will write a description of what you think the correlation will be. Do you remember anything about correlation from class?
Ugh, gosh, a bit. I mean, I know how to calculate like the correlation interval or something like that.
Okay,
That's
so
what I did. Confidence interval. That's not
that's
what I
different. Yeah, that's different. So let's do this. Let's make a chart of the data. So the first thing you do when you get a data set in real life is you always graph it and you like wonder what it looks like. So let's see if this one actually is right. I don't like that one. Let's see. That'll do, I guess. Okay. Do you see any pattern to this data?
Uh, I they're mostly less than uh like under the 4.
So we're looking for like, does the data go up and to the right or down to the right? So now
Not really. I
let me
can't.
add, that doesn't help either. Let me undo that. Okay. So no, this is totally uncorrelated data. And
Okay.
that's kind of what we're looking for here is that because you're choosing randomly,
Yeah, there wouldn't be a correlation.
there'd be no correlation in the data set. So here we go. We want to say something like that here. The correlation coefficient will be close to 0 because there is no correlation between the data when it is randomly uh, select, not really select, randomly,
Assigned?
sure. Uh, Now you can see I already have a typo in there. Excel does have spell check in it that you should use.
Oh, lovely.
You should always spell check things before you send them, which I can't find, of course, but I don't know. It's somewhere, but you should always spell check because it looks bad if you do something like that. Next thing here is it says, then use the command correl. That's for correlation to compute the correlation coefficient. Now create a scatter plot showing relation between data sets and then add it to the least squares regression line for the data. All right, we actually already did some of that. So we're
Mhm.
gonna put this here. We'll write correlation here, and equals 4L, and then you just choose your data sets, and then it gives you a number, and that's pretty close to 0.
Yeah.
Next is to insert a XY scatter plot like this. We're going to add in a title, and we're going to label these. We're going to call this X. We're going to call this other one Y, and maybe just say randomly chosen values.
Okay.
To insert, there's a million ways to insert a trend line. If you right click and add a trend line, it will do it like that. And then you can display the equation on chart, and you can display the R squared value, which is usually important for people looking at this to see. I would probably maybe move the equation off so it's a little more readable, something like that. And you can make this pretty. This is very ugly, but it is. I mean, there's, there's whole classes you can take on dashboarding stuff like this. So
Ugh, so exciting.
yeah, well, you only notice when things don't look right. When they look, just think
Yeah.
how much time you might spend if you're going out on a date and you like the person you're with, they don't know that you spent a lot of time to make it look pretty, and it
No, I
kind of,
spent so much time making my schoolwork look pretty, like this presentation I did in my psychology class. It was beautiful.
yes, and so people don't notice that. They notice when it looks like trash.
Yeah, exactly.
So that's unfortunately the way it goes.
Mhm.
Or you don't notice the dark circles under your eyes until they're not covered with makeup. Um, all right, next one here. We're up to number 4. Um, exercise 4. I should save this every once in a while. Okay. All right, so exercise 4. Let's make this a little bit larger.
Oh, I need to send you this spreadsheet in order to
Using
do
the spreadsheet provided, put the numeric portion of UID in the highlighted
it.
square. Grades from randomly generated by the comp seed ran comp. Do not delete them. Students, their heights. Yeah, right. The appropriate statistical test carry out. You just into this test. Test 99% acceptance level and analysis results. What do you mean? Okay. All right.
All right.
Um,
Give me a minute. I just need to send this to you.
that sounds good. Will you be emailing or dropping in the
Let's
chat?
see if I can drop it in the chat. Would be efficient. Okay, if that works.
All right, I got it. Save. Open. It's instructor did this using something else. Okay. So I'm gonna see if we can copy it into the one we've been using.
Okay.
Is it saying? That's okay. I want to paste anyway. All right. Sorry, I'm just annoyed by these warning signs. All right. Is that your UID or do you need to edit it?
Oh no, that's not mine.
Okay.
Just
If
a
you're
random one.
comfortable, you kind of have to be. You have to give me your UID here. Uh,
Yeah, no. So confusing. What is it asking me to do? Oh, okay.
so at the University of Arizona, they actually use the IDs in the software to grade certain assignments
Mm-hmm.
to see if you actually, because I was going to say we'll just pick one, but they yeah,
Yeah,
they
I
really
think
should.
apparently I'm supposed to use mine.
Yes, you should use yours because they might be able to detect it.
Yeah, makes sense.
So when we get that, and this doesn't impact what the next thing that we do is here, but you're getting a data set, and I just what I did here is just copied it into the true exercise 4 tab. So uh, assume uh, your friend bets you that the average height of the student is 67 inches, and you know the population series is 3.5, right? Appropriate null and alternative hypothesis about the true average height was appropriate test to carry out, so on and so on. Okay. So the first thing here is that you're going to presume that mu, and that's 67 sigma of the population. You could really dress this up by inserting Greek letters if you wanted. Um, won't be doing that. The uh, true average, and then so you have the sample size. So now we're getting into the actual. Okay, you have the X bar. You have the sample size of this. So you got to calculate like the average of this data set. And you know that it's 100, but you could use a count feature to find that. So now we can insert the null hypothesis and the alternative hypothesis.
Yeah.
So if you recall here, it's based on what the claim is, which the claim here is that mu is, I'm sorry, that what you assume to be true is that mu, and you can just, I mean, you could probably just use mu like that. Mu equals 67, mu,
Mhm.
and then does not equal 67.
Yeah.
The reason it's that is because it doesn't say whether you think that the height got bigger or smaller.
Hmm.
I always like to write the claim, like whatever you think might be true.
Yeah.
Um, Now this is a z-test. The reason it's a z-test is because you know the population standard deviation. If you did not know that, it would
Yeah.
not
If
be.
you
So now you
see.
take the average, subtract the mean, divided by sigma over the square root of the sample size, and there's your z-score. Now that's pretty darn, did I
Hi.
mess that up? Yeah. but that is pretty far away. Now, I don't think this is
Hmm.
going to help. Okay, so what your teacher did not specify here, which I don't understand why, but it didn't say here for a particular student. Um,
Mm. About the true average height of the students.
yeah, and it does matter here for this, but this is the only reasonable one. This is what it has to be because of the way this is written.
Okay.
So that's the Z. Now the p value you get from using the normal distribution, and this time though, if you put that Z value in, you're going to get what's called left-tailed, which we actually do not. We don't want that one. We actually want right tail. You subtract it from one, so that looks more reasonable. But because it's a two-tailed test, which you might even throw that in here, you end up doubling this value you just found. And there's your p-value.
Okay.
Your alpha level should have been, I should have put that up. We'll just put it here. Alpha is 0.05. And then you reject / fail to reject. Here you're going to fail to reject because your p-value is greater than this right here. So somewhere you want to say that the z-test is appropriate because the population standard deviation is known.
Mhm.
It says right and appropriate null alternative hypothesis, check. We got that. Now you might want to go in and dress it up with some Greek letters. We can do that in a moment.
Okay.
Um, it also says here, what is the appropriate test? We just said that it's a z-test. The next thing is, what do you need to assume to do this test? We kind of said that population standard deviation is known. Compute the test at 95% significance level and analyze your results. That's the fail to reject. So you might want to go beyond further. You might want to say that there is not enough evidence to support the claim that the mean height is different from 67 inches.
Okay.
That would be like the, A+ student if you want to be that. Then construct the 95 confidence interval for the mean. So you would compute the lower bound and the upper bound. So the lower bound, you take the average and you add in the norm dot s dot inverse. So 0.025, which is your alpha divided by 2, times your sigma. And then you would normally do the square root of n, which is 1. In this case, I guess. I don't really agree with that, but that's what it says. And then you just change the sign. Remember it's plus or minus. You said you're doing some
Uh-huh.
confidence intervals.
Yeah.
There's the other one. You might add in units to some of these to really dress it up. Inches, 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 inches. I don't know. At some point, it probably doesn't look that. It looks like garbage, but it's everything they asked for in there.
Yeah.
Okay.
Perfect.
What would you like us to do to enhance this, if anything?
Um, Maybe just with the rest of our time, we could go over how to find the p-values from the Z and T. I have had
Sure,
trouble with that.
sure.
I just don't really get it.
Anything else on this?
Uh,
Though
no, I think we're good. If I need
it
to,
was good to do
let
one
me
more
know.
quick, run through just to make sure everything's there.
Okay.
I think it is, but I'm gonna look one more time because it's a lot harder to go back on your own and try to fix it.
Okay.
One of the things I always do before I submit stuff is I always cleanse it. I don't know if you can see this, but you should always either copy from the file or go to check for issues, inspect files. You a million Google videos on this, but
Okay.
basically you want to get other people's names off of this. So, all right. I looked it over. Do you have any other questions, thoughts on this before proceeding? Oh, we
Don't.
never got your UID. That was one of the
Oh
big
yeah.
things. Do you have
Yeah.
your UID? Because the only thing
Yeah.
it's I'll just have to copy it over.
It's okay. Yeah. It's 1409548.
Really? Did that change anything?
I don't think so.
All right. I don't know. That didn't seem to change anything. I
Because it's just
wonder.
because the data set is people's height, right? That's
Uh,
what the
no, it's using. Okay, so I didn't. Let me go because I think it might actually impact because I didn't use the data set, the
okay.
file that he provided. Let me try that real quick here. Okay, yeah, it did affect the data set, and so all I got to do is copy and paste. Thankfully,
Okay.
uh, so it actually, thank goodness, did not affect any of our results there. So, all right. Okay, I'll make sure to send that over. You
Okay.
said you want to do some stuff with p-values, is that right?
Yeah, and then maybe just the like one-tailed, two-tailed thing. I don't really get that either.
Okay. Let me share my screen. All right, so let's go back to some hypothesis tests. Let's say mu equal 10 and H1 or HA is that mu is less than 10. And
Mhm.
then you do some stuff and you find that Z is minus 2.09. Is this a one tail or a two tail test? And it's based on this down here.
Um, I'd say
So
one-tailed,
it's one tail. It's left tailed,
less
actually. Left
less
tailed.
than 10, you know.
So
Yeah.
less than. So here's your Z value. So you need to compute the area in that tail there.
Okay.
Now, do you have a table calculator software? Like, what are you guys using for this?
We are just given a table and then I have my calculator, but I can send you the tables we typically use.
It might be good to send it for both this Z and the T table if you got
Okay.
both.
Yeah, I can grab them. It is funny seeing all these spreadsheets. You can just type in some numbers and it will do what I've been working on for 2 months in 10 seconds.
Yeah, I mean, we
Love
should use
that.
whatever you're going to be allowed to use. Like if you're using software, that's fine. I just,
Yeah. It's like, oh my gosh, why do I need to learn this when I can just
yeah,
put it in my computer?
good question. It's
Good question. But yeah, I have to take statistical methods in psychology next semester, so
it'll be you'll have a lot of the same stuff
I gotta be prepared. Yeah,
to do
I'm
it.
glad I took this class, although it was annoying, but worth it, I think. And then this one. Okay, so um, table A is Z values and table C is T.
Okay, so what I'll do here is I'll show you, you got to be able to find this Z value on the table.
Mhm.
And that's the, that's the challenge here. So here we go. So on the left is the Z to one decimal place. And on the top here is the second decimal place. So
Yeah.
minus 2.09, you go down to the minus 2.0 and you go all the way over there to the nine. So it's 0.0183.
Mhm.
And that is the answer.
Yeah. Like Z values like make much more sense, but when you have to do like the in between thing for the p value, I just don't get that.
Well, we'll do a Z right, left, in between, and then
Okay.
we'll so let's
Sounds
say
good.
another problem, your null hypothesis that mu equals, 500. HA is that mu is greater than 500, and you calculate your Z and it ends up being 1.67. Okay, so because it's right-tailed, why is it right-tailed in this problem?
Because it's greater than
Yeah, it's
mu2.
right-tailed. So you want the area to the right of 1.67.
Mhm.
So when you go to your table, I want you to look up 1.67 on your table and tell me what value you see.
Yeah. It's 0.9525.
Now the problem with this is that that is the left, that's left of
Uh-huh.
this number. We want right of it. So you have to
Yeah.
subtract it from one.
Okay.
So you end up getting 0.0475. Is that okay?
Makes sense.
All right, now let's the two-tailed, the most, let's say mu equals 1.5, H1 mu does not equal 1.5. That's two-tailed. And let's say you get your Z value of 1.78, 1.78. So
Mhm.
this time it's two-tailed, which means that you get the area to the right of that, and then you double it because you also want the area to the left of minus 1.78. So you actually have two options. You can either go to the table and look up 1.78 like we just did in this previous problem, find the area and subtract it from one. That'll give you the right tail.
Mhm.
Or if you can remember to look up the negative of that, the negative will give you the area and then you just double it.
Okay. So that would be
So I would tell you to look up the minus 1.78.
yeah.
That will make the most sense for you.
Okay, so negative 1.78 is 0.0375.
Uh, yeah, 0.0375. And then you double it. So you do 2 times 0.0375, which becomes 0.075.
Okay.
Right?
Yeah.
So now to the p distribution. Okay. Just a little bit more effort involved here. All right. So on the t distribution, you notice degrees of freedom.
hmm
Oh, do you have another, P? You have a table B.
Gosh, that is, those are the only ones we use.
Okay. So this one you're using for confidence intervals.
Okay.
So when you're using your T table, I have to tell you, I have to say, I want a 90% confidence interval on my sample mean. And I have to tell you that, oh, there's 14 samples.
hmm
And you don't want that value. You want the degrees of freedom, which is n minus one. which is 13.
Yeah.
So here's how to use the table. So you grab your table, and you can see on the left-hand side is the degrees of freedom.
Yeah.
That tells you which row you're in.
Hmm.
The confidence interval tells you the column.
Yeah.
So that's when you're writing from x bar plus or minus t alpha over 2 times s divided by the square root of n. That 1.771 is the t alpha divided by 2 value.
Okay.
Any questions on that?
So, okay, so the alpha is that's what they give you of
Well,
like
they have to
is
they have to
this
tell you that they have to tell you the confidence level. They have to
yeah,
give you
is it like
C.
statistically significant at this level? Is that what they would ask?
No, that's something different. This the
Oof.
way this table is, it's purely for confidence intervals.
Okay.
Although we could do area, but that's a little bit more challenging. Have you been having to compute p-values from the t-table?
I think that's what we do, yeah.
Because the difference here, the difference is you don't have it. You have to find your t in this table based on the. This is where it's tough to do. My guess is you have not been doing that. I know you said you did, but like,
Don't
let me
know.
try to explain what happened. They would tell you, you would know that the degrees of freedom is 9, and you would get a t value of like 2.358. Okay, so if you go to the row with degrees of freedom 9, you'd want to find the one that's closest to this 2.358. So see how it's between 95 and 96%.
Uh-huh.
Your p-value, your p-value is somewhere between 0.04 and 0.05. Is that what
Yeah.
you were doing?
Yeah.
Okay, well then I'm wrong.
Yeah.
So,
It's like I don't get it, but
well, you got
now
to
I have
find
to
that
answer
you got to find that number in there.
it. Yeah. It's
I
like
mean,
I
that.
think I've been doing it right. I just don't know why we do that. Like,
Well, so the reason is that the P has to be computed based on the degrees of freedom, so they don't have as much visibility into the table.
hmm.
That's why it's always done in software, because the
Yeah.
computer can always do it, the human cannot. So if I gave you a problem where the degrees of freedom was 7, and I tell you that T was 3.01, you would go to row 7 here,
Hmm.
and you'd say, well, where does it fall? Well, it's basically there, but there. So it's probably closer to 0.02, but it's between 0.02 and 0.01. Um,
Yeah.
and so they probably had you finding the critical value and then comparing to it, or they had you use your calculator to calculate it.
Hmm. Yeah, and it gets tough, especially with these huge samples when the
Yes.
degrees of freedom is into the hundreds.
Right.
You're like,
So
okay, well, where am I going to put 167 when
yeah,
it's not even,
that
there's not even a row for it?
that's a good question. And the
It's
answer is that
tough.
you're not supposed to use the table. You're supposed to use software, or you're supposed to use like you actually would use row 100, because you would be less likely to have an error by using a smaller sample size.
Okay,
But that should be covered by your instructor. Like I can't direct you on that.
that's a that's a him problem. Yeah, I don't know. He's been missing a lot of class. I didn't even know you could have substitutes in college classes,
You can.
but
It's a little weird,
yeah,
but
that's a thing.
like with Zoom, I mean, geez, you can do it from anywhere. I
I
don't quite understand
know.
that, but
Like record the class or something, but it's it's been fine.
all
Yeah.
right. Anything else you want us to cover today?
Um, don't think so.
All right, let's go.
I finally figured out how to get